Okay, so here are my two collections. Again, this is my domain. There's my subdomain. The values I actually use are going to be called my range. And the rule that I'm going to propose is I'm just going to call the purple lines. And the reason I'm doing that is because I don't want to, I'm not going to actually define a rule. I'm just going to say, look, here's the rule. Does this qualify? 3 goes with -8. 2 goes to -4. 6 goes to -10 and to -12. And 10 also goes to -12. Is that a function? Why not? Okay, it's not a function because 6 goes to 2 values. And the rule is to qualify as a function, every item in the domain gets assigned 1 value in the subdomain or the range. You can't do that. So since I made 6 go down here, that doesn't work. Now if I add on to this the number 8 over here, and I say, all right, we'll get rid of that. Oh, and I want to add 12 over here. So there's my change. 6 no longer maps to -12. 10 goes to -12, and 12 goes to -12. So new rule. With that change, so 3 goes to 8, 2 goes to -4, 6 goes to -10, 10 goes to -12, 12 goes to -12. Is that a function? I got 2 numbers going to -12 now. Is that okay? As long as you're only using every item in the domain once to pair over, yeah, that's okay. It's a function. And now let me actually write this out. So the domain is made up 3, 2, 6, 10, and 12. I use these curly brackets to border that. The range, curly bracket, -4, -8, -12. Oops, I forgot -10. Curly bracket. With what? Range. So my domain and my range. Now, traditionally, we tend to use, when we do functions, we tend to use a mathematical expression as that rule. It tends to make things flow a little more easily. It seems to fit neater into what we end up doing. But I like to start off with stuff that's not so rigid at first. Help get the concept down, and then we can continue to move into things that fly better. So, for example, let's say I take the domain of 1, 2, 3, 4, and 5. So there's my domain. And the rule is going to be this function is, let's do x squared. That's the rule I'm going to use. I don't know if it's a function or not. Hopefully it is. What will be my range? If I'm not sure, let's make a table of values. 1, 2, 3, 4, 5. Get that up there. All right. So let's see. If x is 1, what's y? 1. And then 2 would be 4, 25. So my range would be 1, 4, 9, 16, and 25. Is this a discrete or a continuous function we're looking at? What do you think, Miriam? Discrete or continuous? For this function. This is my domain, here's my range, here's the rule. It is a function, but is it discrete or continuous? Do I have all the numbers between 1 and 2 included, or just 1, 2, 3? I do?
No.
I only see 1, 2, 3, 4, 5. It's only those numbers, right? And I only have these as my result. So this is discrete. Because it's specific values. Now, if I had talked about the domain being all real numbers, that is a hint you're looking at continuous, because there's all those numbers in between as well. But here I'm just doing those guys and those guys. The continuous would be if I had said, I'm not going to ask you to plot every point, because I'm allowing it to be this big group of points. So for example, if I had said the domain, I'm not going to do this, is all the numbers between 0 and, well, I'll stay consistent with 5. And x is all the numbers between them. Now if I had done that, that's continuous now. So I'm opening it up for it to be 1, 2, 3, 4, 5, and a half, and 1 3/4, and 1 7/8, and 1 and 60 seconds, and so forth and so on and so on. That creates a continuous now, a big group. When I break it down to specific values, we call that a discrete function. Because there's something going on that I only have these 5 inputs. If I were to, like, for example, map class size over the course of the year, we've had a few less students when we started, we've added some students, it would be a discrete function, because I don't add a half a student. Some of you guys act like half students, but technically you are a full-bodied student.